Well, the answer is this one. This is the path that the light is taking in the unprimed frame. It's moving at this slight diagonal. That means the total d prime, this whole distance up and back down, is 2 times ct prime. Okay, so this side is ct prime, this side is h, and this side, well, it's v times t prime. It's the speed of the train, v, times the time elapsed. That's how far the train has advanced. So actually I have this wonderful right triangle. Base, height of h, and hypotenuse of ct prime. I'm going to do the Pythagorean theorem. This squared plus that squared must equal this squared. And when I do that, I get v squared times t prime squared plus h squared equals, well, this side squared. And I'm writing the t primes in red just so we can keep focus on them. Now actually what I want to do is I want to solve for t prime. So I'm going to move this term over to this side. And what I've done here is I've factored out the t prime squared. And now I'm going to divide both sides by this c squared minus v squared. So now I have this. My next step is a bit of a trick. So what I'm going to do is I'm going to divide both the numerator and the denominator on the left-hand side by c squared. And since I'm doing it to both the numerator and denominator, that's totally fine. And what I get when I do that is this. And now maybe you can start to see why I decided to divide by c squared. I did that because when we look at these two equations, these are both d, so I can set them equal to each other. 2h equals 2ct. The 2's cancel. And t is equal to h over c. Remember, this is the unprimed t. So what I can do is replace this h over c with t. Now what I have is a relationship between the time measured on, well, unfortunately I erased red, but measured on red's clock, and the time t measured on green's clock. Let's just take the square root of both sides, and I find that the time measured on t prime, the red clock, is equal to the time measured on this guy's clock with this mathematical expression modifying it. I would have no reason to believe that two identical clocks should ever run at different rates. But what I've found here is that it's not only that the clocks are running at different rates, but that time itself can't be universally specified. My time is not the same as your time if we're moving relative to each other. This is amazing. Let's look at this equation in a little more detail.